Okay, so first thing we're going to do is we're going to make sure all the journals and the crankshaft are clean. And we're going to use these bottle brushes. And we're going to find all the holes. So here's one here. We're just going to run it through. And it's going to go through the journal and out the other side. And the mains feed the rod. So it goes through and it comes out. Now I'll show you guys. Let's see. So this one comes through over here. See that? So all of them come. So this one comes through on this main. This one comes through on this main. So that's just how these things are lubricated. So we've already had this crankshaft washed at the machine shop, but I always check it before I install it. There's just too much problems if this isn't done and there's something in there. Brush. Alright, so those are all cleaned out. They're all clean. And one of the things I should probably point out is that we had this crankshaft bob weight balanced, which, let's see if you can see these. Down in there, you can see these two holes that were punched out. That's because the connecting rods we're using are actually lighter than the factory ones. And to compensate for that, they had to do this to the crankshaft. So one of the things you have to pay attention to is if you're changing the weight of any of those components, a piston or a rod, then this needs to be rebalanced, what they call a bob weight balance. Now what I'm going to do is check all the clearances here, the mains and the rods. I'm going to write them all down, and then we're going to compare them to what the factory clearances are supposed to be. Alright, so we're going to check the main clearance here. Okay, so let's measure that out. Oops, touch the side. So one of the things we learned a while ago, we had a car that made 622 foot-pounds of torque to all four tires, is that the rods are kind of a weak link. But before I say weak link, that car was making over 700 foot-pounds of torque when we made the rods low compression rods. We actually squished them down a little bit. So this rod is slightly shorter than a stock one. And you can see the wear on the thrust side. See that side? And look at this side. All right. So it was not straight in the bore anymore. We were able to just, once we saw it was running a little bit rough, we pulled, we stopped the car and, brought it back and took it apart and found the rods. And that engine got a set of Potter rods. Shout out to Potter rods. We like you guys, but out of the budget this time. We're using some Silly Rabbit Motorsports rods, which look pretty cool. We know some people that have run them. And the guys at Silly Rabbit have been really supportive and nice. We like them. So I want to teach you a little bit about this. So this is a Mala piston. You can kind of see the M at the bottom, right? So this is a factory Mala forged piston. I measured the crown thickness, and it is 0.245. And, and the wrist pin, right? Look at that. I couldn't tell you the material on that exactly, but the wall thickness is 0.177. That's a stout pin. And when we pulled apart our motor that made the 700 and something foot-pounds of torque, the wrist pins were happy, the pistons were fine, the bores were fine, the crank was fine, all the bearings were fine. We just replaced the rods, and that motor is still running today, years and years later. On this one, you know, we like to change the things that are necessary. So we're going to keep the factory pistons. This piston has, 200,000 miles, and I can't feel anything on this. No, nothing from my nail. It's perfectly even. Then you look at the piston. Some of the coating is scraped off, but there's still plenty of coating down in the grooves. It's hard to see, it's still down there. And then over here too. Right, this is the side that got a little hotter, right? So we're going to reuse these, put new rings on it, and a new set of rods and bearings and everything, and off we go.